Okay, so the question now is, what are fluids? Yun yung muna natin pag-usapan kasi we're now dealing with fluid mechanics. Uh, when we say it's a fluid, it's in a layman term, in a nutshell, fluids are basically anything, any matter or any substance that can flow. Yeah, that's the basic definition of what fluids are. It's any substance that can flow. Basta nag-flow yung substance na yan, fluid yan. And then, so ibig sabihin, gases can flow. Therefore, gases are also part of fluids. Hindi necessarily liquids lang ang fluids. It can also be gases. So, fluids include both liquids and gases. We are assuming here that the gases are have high densities para talagang nag-flow siya. Pero pag medyo low density, medyo mas simpler yung analysis dyan, hindi siya more on fluids. But the point here is, yes, liquids and gases are part of fluids. And then after that, these are not rigid bodies kasi nga, hindi nga rigid eh. It will only take the shape of its container kasi fluid nga siya. Gases are like that. For example, a bromine gas, wala tayong picture dito. If you have a bromine gas, pwede mo siyang itapon sa from one beaker to another. Sayang, wala dito yung picture nun. It's a gas, but it flows like a liquid. So it is a fluid. Okay, and again, fluids are not rigid bodies. Therefore, of course, they will change shape kasi nga nagpo-flow nga sila, di ba? So yon. But both fluids and rigid bodies, as I said, are continuous systems. So they are composed of particles. But we will first ignore the particles themselves. We'll only focus first on of the nature of them being fluids. Okay, being something that's flowing and something that's continuous. So indivisible siya indefinitely. Hindi mo na natin titignan yung pagiging atoms or yung molecules and atoms that are comprising the fluid. Hindi sa atin importante ngayon yan. Okay, and then also fluid mechanics is a discipline. It's composed of two: fluid statics, meaning that the fluid is at rest, and therefore what quantities can be obtained if the fluid is static or if the fluid is not moving. If the fluid doesn't flow. And then finally, we also have fluid dynamics, which we'll be discussing on lecture 28. We'll focus first on so for fluid statics, it's lecture 26 and 27. This is today and next session, which will be on buoyancy. And then for fluid dynamics, we'll only consider the very simple case of ideal flow in fluid dynamics because fluid mechanics in general is a complicated field. Yeah, we'll only consider very simple cases in this course. So, yeah, medyo complicated ng fluid mechanics. Okay. Now, so of course, we are familiar with the notion of density kasi instead of taking the total amount of masses, for example, we are usually in fluids, we are dealing with densities. Lahat ng mga quantities na consider natin dito, usually the densities ang pinag-uusapan. So the mass density rho of a uniform object of mass m and volume v is given by rho is m over v. So in general, hindi yan totoo. Ang assumption dito is that yung pagkakapak ng molecules or ng particles dun sa object ay uniform. Therefore, walang areas na may lumps, walang areas na mas malawag yung spacing ng mga particles. But we will assume here, kaya uniform yung density mo. The density is constant, which is just equal to the ratio of the total mass over the total volume. So, I'm strictly speaking, it's the mass density because you will encounter in Physics 72 the notion of charge density. So, hindi lang naman mass ang may density, pwede rin charge. Okay? So, for the meantime, dun muna tayo mag-focus sa mass density. Okay, now, so of course, the SI unit for mass is for density is kilogram per cubic meter. This is the volume mass density, strictly speaking, kasi pwedeng area or linear yan. So here this table here shows the different densities or mass densities of uniform materials. So for example, air has a relatively small density, it's just 1.20 kilograms per cubic meter. So if you have a cubic meter of air, you can and you weigh it on a platform balance, for example, you will get about 1.20 kilograms. So, inaassume natin uniform yung air. Diyan. And then other quantities like ice, water, seawater, blood, these are in order of 10 to the thousands of kilograms per cubic meter. So medyo mabigat sila kapag binuhat. And then of course, neutron stars are really exotic objects in the universe. So medyo malaki ang kanyang density. It's one of the, I believe it's the densest material that we have that that we know or that we're aware of. So I'm not sure if it's correct. Please correct me if I'm wrong. Pero sobrang laki ng density niyan to the point na kapag meron ka lang scoop ng neutron star, kasing bigat na niya yung Earth. Sort of, parang ganun. Or it's a really large, sobrang tightly packed ng mga particles na nasa loob ng neutron star. Okay? So yon. Usually naman sa exams or sa problem sets, bibigay itong mga items na to. So usually binibigay yan. Di yan pinapahulaan sa estudyante. So don't worry, hindi nyo kailangan basibuhin yan. It's always given. Okay. So the density can be used as a unique identifier of a substance if you kasi for uniform substances, yung density ay property niya. So wait. Okay, so as I said, density can be used as a unique identifier for any substance. So if you have a substance, medyo intrinsic yung property na yan. Kasi remember, it doesn't depend on the volume of the substance. So kahit maliit na object, for example, a small piece of lead and a large piece of lead, assuming that the packing of the object is uniform, then yung density niya same pa rin. Of course, obviously, another thing is that the density of water shown in the table is at 4 degrees Celsius. Kasi nagbabago ang density ng water depending on temperature. So you will see that in your chemistry classes or kung may physics 73 kayo sa 73 yan, that the density of water is not constant, it changes. Nagbabago yan. Okay? But for convenience, we will assume that the density of water is about 1 times 10 to the 3 kilograms per cubic meter. Okay. Questions? So, may tanong ba? May tanong ka ba? Wala? Okay, next.
None po.
Thank you. Sige. So, specific gravity on the other hand, sabi ko nga kanina, specific gravity, para lang yung density. However, specific gravity is a unitless quantity. It's just basically the ratio of the density of the substance over the density of water. So, if you check that the specific gravity is sometimes medyo nagkakaiba ng numbers depende sa kung paano mo mine-measure yung density ng water. But in general, kung ano yung density mo, yung numerical, the specific gravity has the same number as of density. Magkaiba lang yung magiging units because as I said, the specific gravity is unitless, the density is not. So yon. So again, as I said, Sg is the ratio of the density of the material with the density of water at 4 degrees Celsius. Kaya 1 times 10 to the 3 kilograms per cubic meter yung magiging density ng water. Yan. Okay, and then, so for example, the density of blood is about 1.06. This is really creepy though. Sorry for that. The specific gravity of so the density of blood is 1.06 times 10 to the 3 kilograms per cubic meter, and hence the specific gravity of blood is 1.06. Okay? So may mga different examples. Okay. Now,